Okay, this video is about geometry lesson 3-6, all about perpendiculars and distance. I'll be doing two problems. Okay, so I'm going to do number 6 and number 10 from the homework. Okay, so first thing, number 6 says that line L contains points 4 and -2 and 2 and 0, and point P has coordinates of 3, 7. Okay, so if you want to get a visual of this, you would put a point on a graph, -4, -2, there's a point, and then 2, 0, there's a point. Okay, and this is a line, so I will try to draw this as straight as I can. Okay, and then there's this other point, point P, that has coordinates 3 and 7. And we want to find out how far this point is from this line. Okay, now the shortest distance between any two objects is a straight line. So we have this point and this line. So we want to find the distance, and the shortest distance, since it's a straight line, is going to create a right angle. So this point is perpendicular to this line here. Okay, so the first thing that we want to do is find the equation of this line here. We'll call it L. Okay, so first thing we need to do is find the slope. Remember, slope is y2 minus y1, okay, over x2 minus x1. So that's going to be 0 minus -2 and 2 minus -4, okay? And we end up with 2/6, which is equal to 1/3, okay? And then what we want to do, since we now have one of the points, we have 2 points, and the slope, we can write an equation, right? So I'm going to use y equals mx plus b to figure out what b is, okay? So, and I'm going to use the point 2, 0, okay? So I have 0 equals 1/3, 1/3 instead of, this is my y value, right? And then instead of x, I'm going to put a 2 and then plus b, okay? So that's going to give me 0 equals 2/3 when I multiply 1/3 times 2 over 1, okay? Remember, you just multiply straight across for fractions, okay, plus b. So I subtract 2/3 from both sides, and I get -2/3 equals b. Okay, so my equation is y equals m, which I know is 1/3, okay, x minus 2/3, which I just found out was b over here, okay? So then that is the equation of this line here, right? So now we want an equation for a line that goes through this point, okay? So let me change the color here. Okay. So again, I'm going to use this y equals mx plus b, and the point, remember, is 3, 7, okay? So I'm going to try to figure out my b value. I'm using 7 for y, and m, the slope of this line that's going through this point is, since it's perpendicular, the relationship is perpendicular, then we know that since we know the slope of the other line is 1/3, remember, perpendicular lines, the slope is opposite reciprocal, right? So I know that the slope of this line is going to be -3, opposite reciprocal. And then for x, I'm using 3 from the point, and then plus b. So I end up with 7 equals -9 plus b. So I add 9 to both sides, and 16 is equal to b. So my equation of that line is y equals -3x plus 16. Okay, so now I'm going to solve this by using I'm going to solve this system of equations. Okay, so let me change this color here. So I have the two equations, y equals 1/3 x minus 2/3 and y equals -3x plus 16. And I'm going to use elimination to solve this system of equations. So I'm going to multiply this equation by 9, and I end up getting 9y is equal to 3x minus 6. And I multiply 9 by 1/3 and 9 by 2/3. Okay, and then I'll just rewrite this equation. Well, it's pretty lined up. So now I have these two equations. I'm going to add them. This cancels out. So I end up with 10y equals 10. Divide both sides by 10, and y is equal to 1. Okay? And then, so I have one of my points for my point of intersection. So I'm going to use 1 in for this equation here. So do that different color. So I have y equals -3 times 1 plus 16. So I end up, I subtract 16 from both sides. Oops. Oh, sorry, I should have put in 1 for y. I just figured out 1 was y. So 1 is equal to -3x plus 16. Because we have the value of y, we're trying to figure out x, okay? And that's our point of intersection, okay? So this would be subtract 16 from both sides, and I end up getting -15 equals -3x. Divide both sides by -3, and I have 5 is equal to x. So now I know my point of intersection is 5, 1. Okay, so if you look at our graph here, over 5, up 1. Okay, so I just drew it a little bit off. Should be, my line should go like this. Okay. Okay, so our point of intersection, and then we have this point here, the original point, 3, 7. So now we want to find out the distance. Okay, so now we have the 2 points. Now we can find the distance. So we use the distance formula for that. Okay. So okay. So for distance formula, oopsie, sorry. So remember, for distance formula, that is the square root of x2 minus x1 squared plus y2 minus 1 squared. And remember, the 2 points were 5 and 1, and 3 and 7. So I just plug everything in. Now 3 minus 5 squared plus 7 minus 1 squared. And then I end up with -2 squared plus 6 squared. And then I have 4 plus 36, which is equal to 40. And we can break this down because there is a common factor of 40. That's a perfect square. Okay. This is the square root of 4 times the square root of 10. And the square root of 4 is a perfect square. So we take the square root of 4, that's 2, and we still multiply it by the square root of 10. Okay, so that is the distance between those 2 points. Okay, all right. So then for problem 10, okay, for problem number 10, for this one, you just have two equations for these 2 parallel lines, okay? So the first thing you should do here is sketch these parallel lines on a graph. So for y equals, I'll do this one red, y equals 3x. Your y-intercept is 0. And then your slope is 3. So you would go up 1, 2, 3 over 1. Oh. Okay. And then up 3 over 1. Up 3 over 1. Or you could go down 3 over 1. Down 3 over 1. Okay. And then for your parallel line, this one here. Okay, there we go. Your y-intercept is 10, and then your slope is still 3, because remember these lines are parallel, so you go, there's no room to go up, so I'm just going to go down 1, 2, 3 over 1, down 3 over 1, down 3 over 1, down over 1. Okay, down 3 over 1. Okay, so there I have my 2 parallel lines. And then what you want to do is sketch a line that goes through the y-intercept, okay? So we're going to call this line A and this one line B, okay? Now, the y-intercept, there's this line crosses the y-intercept at 0, okay? So I know I'm going to be going through this point, and then I know that, remember my slope, I want to make a line that's perpendicular, right? So I know that my slope is going to be opposite reciprocal, so it'd be -1/3, okay? And it crosses the y-intercept at 0, okay? So at this point, my slope is -1/3, so I'm going to go down 1 and to the right 3, down 1 to the right 3, or I can go up 1 and to the left 3, and up 1 to the left 3, okay? And then there's this is going to be a perpendicular line, okay? Now, honestly, at this point, I have this point of intersection, 0, 0, and notice that it also crossed this point here, exactly the same point, which is another point of intersection, okay? So technically, I do have my 2 points of intersection that I can find the distance of, which you could do that at this point, but let's say it wasn't exact like that, and we're just going to go, I'm going to go through and show you the steps, okay? So what I want to do is write an equation for this line. I'm going to call it P, okay? I know that the slope is -1/3, okay? Because remember, it's perpendicular. So it's -1/3 x. I know my y-intercept is 0, right? And so it's just y equals -1/3 x, okay? So now what I want to do is use systems of equations to determine the intersection of these 2 points, or yeah, this line here and then line A, okay? So my equation for line A, okay, which is this one here, okay, is y equals 3x plus 10. And then the equation for line P, the one that I just determined, was negative 1/3 x, just like that, okay? And so what I'm going to do is I'm going to use substitution to solve, to find the point of intersection here, okay? So both of these have been isolated for y, so I'm going to plug in, I'm going to set these two equations equal to each other, okay? So 3x plus 10 is equal to negative 1/3 x. The reason I did that, y is equal to 3x plus 10, and we're saying y is negative 1/3 x, so I just set them equal to each other, and then I can solve for x, okay? So I would subtract 3x from both sides, and I would end up with 10 equals negative 3 1/3 x. I would divide both sides by 3 1/3. Excuse me, negative 3 1/3. So when you divide that out, you end up getting negative 3 equals x, okay? So now I'm going to plug in, I know x, I have one of my points, I need y, so I'm going to plug x back into the equation y equals 3x plus 10. So to figure out for y, so for x, I'm going to put negative 3 plus 10. So this is y equals negative 9 plus 10. So y is going to equal 1. And then finally, we have our second point here, right? We have x is negative 3 and 1. So we have our 2 points, which, remember, like I said earlier, notice it was at negative 3, positive 1. So drew that graph accurately, and it was right on the money right there at negative 3, positive 1. So now the last thing I have to do is find the distance between those 2 points using the distance formula, okay? So I'm going to go ahead, clear that up. So remember, the 2 points that we're looking at are 0, 0, which was our y-intercept, and then the point we just figured out, the point of intersection, which was negative 3, positive 1. And so our distance formula, remember, is distance equals the square root of x2 minus x1 squared plus y2 minus y1. And we're taking the square root of that, okay? So we just plug in our x and y values. So we have negative 3 minus 0 squared plus 1 minus 0 squared, square root of that. And then we end up with negative 3 squared plus 1 squared. And then that ends up being 9 plus 1, which is equal to 10. Okay, and there is no factor of 10 that's a perfect square. So that is as far as we can go. Okay, hopefully this video helped you out with these problems. They're a little time consuming, but to make sure there's a lot of room for error there. So make sure, like on a quiz or a test, that you're showing all your work. Okay, all right, thanks.